Welcome back to Control-Alt-Lead, the podcast from computing where we talk with IT leaders about what's moving in the market. The network edge is where we often find small, low-power applications like IoT devices and other things that require low latency and high efficiency. With the rise of AI, some companies are looking to see how they can bring these big data-intensive tools to the edge of the network. To discuss that topic, I'm joined this week by Paul Williamson of Arm, and we're talking about how AI and edge networking are building on each other to evolve. We talk about everything from the adoption of small, hyper-trained AI models, small language models, to different use cases for AI at the edge, like bear spotting, or beetle infestations, or beer brewing. We didn't actually talk about beer brewing. It does make a nice alliteration along with bears and beetles, though. We did talk about how the changing behavior of software developers is forcing hardware changes, which of course has a knock-on effect at companies like Arm. Please enjoy. Paul, thanks so much for joining me today on Control-Alt-Lead. It's great to have you here. We're going to be talking about AI and edge computing. So let me start off. AI obviously is known for needing huge amounts of data and compute. So how does that work when it comes to AI at the edge?
Yeah, I think that's a good starting point to think about AI. I think most people, as you've said, are really familiar with the sort of chatbot chat window requiring a huge data center behind it to navigate these models, these huge, very general purpose models. But in the future and in the developments that are happening today, we're seeing AI being adapted to specific expert tasks. And that means that we can deploy it in edge applications. So effectively what is being created are these special, if you like, expert systems or compressed AI models that are very suitable for individual tasks, and that allows them to be deployed in much smaller compute footprints closer to the edge of the network for a range of reasons, depending on the application, that improve efficiency or lower latency. So it is a different use case when you see it deployed in these edge applications often.
Okay, so in that case, we could kind of say that edge computing is changing AI, or is it the other way around? Is AI changing edge computing?
I'm seeing things happen in both ways. I'm seeing people in edge computing who would have perhaps traditionally used other techniques like digital signal processing or other methods move to using edge AI for compute. So they're, even things like the microphones we're perhaps talking on now, traditionally that would have been a task for a signal processing task where people are looking at frequency spectrums and making adjustments. Increasingly, we're seeing AI applied to those applications. So it is changing the kind of compute that's used in existing compute applications. I think also we're seeing sort of edge compute change AI. So a big trend, the early development effort was in these super large general models to cover everything. And increasingly, we're seeing efforts for, you'll hear about smaller llama models or smaller large language models being deployed with fewer parameters that are more constrained or tuned down. And that allows you to run them in smaller computing footprints with lower latency as well. So I think both is happening at once, which makes it really interesting.
Yeah, those are often being referred to now as small language models, aren't they? As opposed to the large language models.
Yeah, that's it. And you can shrink a model in a number of ways. You can use mathematics principles to quantize it, which means, using fewer bits of precision, if you like, in the model itself, or you can, constrain the data set on which it is built to fit into a smaller footprint, or make it more application specific. So an example we've given recently is showing something like a small language model that focuses on a particular task. So a great example our embedded team showed running on a battery powered device was something that could write bedtime stories for you. So rather than being able to tell you everything from the laws of thermodynamics from first principles, this thing just has learnt on a smaller data set of English language children's stories, and you can ask it to write you a children's story with particular characters and it will do a fantastic job of doing it. But it can be a much smaller model because and therefore fit into one of these sort of embedded applications because it's been trained on a much narrower data set. So it becomes an expert system at storytelling.
Right. So we've covered a few applications of AI at the edge recently on computing.
Okay.
So I suppose I'll ask you, is that a trend? Are we seeing a rising demand across the industry for AI at the edge or for high performance IoT, shall we say?
I think so. So as we look, there will remain a class of devices and applications that are well served by existing standard compute models. I mean, I've got a thermostat on the wall behind me that, it doesn't need AI today. I'm sure people will think of applications of AI in those kind of systems, or a remote control for your TV or a light switch. They are typically on, off, or simple logical control, and they will make sense. But increasingly, there are a broader number of applications, and people are exploring ever more interesting examples of where you can apply AI for genuine advantage. And perhaps the familiar ones are these agents running in the cloud, so customer support or helping you fill out your tax return or who knows what. But we're also seeing them at the edge. And I like examples I've seen in areas like agriculture, where previously the compute needed to analyze video or to look at images was quite high. But with these new AI models, you can use actually quite small, compact compute to detect things. And one example of this that I talk about frequently was an example I learned about of vinicultural wine production in northern Italy, where they're blighted by a certain type of beetle that affects the crops periodically. And what they're able to do now is, just with this tiny little camera module and a very small microprocessor, is just take an image sample of an area of leaves once every few minutes and say, is there evidence of beetles? And they can therefore get a really early predictor of the presence of the beetle on the crops in the season. They can spot treat rather than mass pesticides. Huge advantages to the local region in managing the wine crop. But they're able to do that now, which couldn't really be done before without an immense amount of processing. So you can have these very low cost sensors spotted throughout the vineyards. And previously it was either incredibly expensive, complex compute, or an individual going around checking leaves periodically. And so it's changing these workflows and use cases, even in these very embedded applications.
Mm. And so these applications don't need a constant connection to a large data center then?
They don't. It very much depends on the application. Clearly, the rate of change or response you need for something like that is, every few minutes and maybe a single sample. We expect, or are seeing, a broad range between sort of cloud connected or always in the cloud. So you might run your customer service chatbot or your something like that in the cloud, a bit like we expect Copilot or something like that to exist on our cloud-based systems. But then at the other end, you've got the devices that can just have connectivity to flag for an event, but they take all of the judgment locally using the AI model that they're executing. And then in between that, you'll have different levels. So you might have, say, in the industrial environment, a fault inspection camera that's looking at products coming off a production line. And it might say, I can see a fault, but it may not know what to do about that fault or what the issue really is. But it's enough to identify that something's off, and then send the data up to a cloud-based agent that can look at that and say, right, this suggests that this machinery is out of tune, or the paint gun needs adjusting, or whatever it is, and can then guide an operator to make an improved decision. So you can also have these sort of hybrid systems of edge systems that then fall back to cloud for more richer data once they've identified that an event of interest has occurred.
Okay, so you've mentioned a few really interesting applications there. So what is causing this rise in AI at the edge?
I think it's a mixture of opportunity here. Clearly, there's an opportunity to do new things that people didn't realize they could do before, and that creates commercial opportunity either through improved efficiency or for new services that people hadn't anticipated. So there's a an understandable race in markets for the competitive advantage that this technology might bring. And some of those in the bigger picture, if you step back and you think about, for example, a production line operation, if you can install that with higher performance compute and cameras, that can be much more flexible than a historical system that might have relied on very application specific metrology or measurement systems that had to be built for every different production line. You can sort of see that the investment in a larger, higher performance compute capability for a production line can pay dividends over potentially 20 years of operation on a range of different applications. So people can see that it offers efficiency and new capabilities, which means that I think there is this sort of race to see how people can use it to innovate and drive their business, either their productivity or their performance in their business areas.
Okay, let's explore that balance between efficiency and capabilities. What are the challenges when you're trying to do that, when you're trying to balance performance and power efficiency, say, at the edge?
Yeah, I think that's a really interesting challenge for developers and companies coming into this area. It's new to many companies, so many won't have necessarily that expertise in-house. I think when it first is emerging, always the software and tools to make a decision around what is the right sort of system to build in to be able to support me for the next 5 years, 10 years, can be quite challenging if you don't have that expertise in-house, or it may be the first time that you're rolling this technology out. So I think a lot of these innovators are, certainly we've seen in the early stages, looking to external expertise. So, there are good examples of companies, even large scale companies, who've then gone and employed, technical specialists or consultants, or, partnered with companies who've already developed algorithms to look at how can they apply them in their business. And then what you will see them do is perhaps invest in tuning those systems for use in their specific application. And then there's others who are looking at, embracing new tooling and software that is emerging, but building that expertise in-house. So we're sort of seeing two models of how people deploy it, but they've clearly got to make a decision around, as you say, the underlying hardware platform as well. And I think you do have to look at the specific application. Clearly, the vineyard example, you needed something low cost and low maintenance that could run off a battery. And therefore you have a threshold of your compute, and you have to look at, okay, that might mean I can only sample once every 5 minutes. Is that okay? Or does that break the use case? You're not going to use that same system for inspecting a production line of, contact lenses flying past at thousands a second, where you might need a super high resolution and a really high performance compute to be able to process enough frames per second. So often the application is dictating the compute requirement and the envelope that you need in performance terms. And so for us at Arm, it's really important that we have that scalability from these little battery powered devices through to these emerging higher performance systems to be able to provide that and have as much as possible a common software developer flow from end to end. So if you have invested in an algorithm that's great for really low power, you may still be able to deploy that in a higher performance system, so you get as much software reuse. Because I think actually, often that expertise around the software development process can be the biggest investment for companies rolling out the technology.
Yeah, absolutely. Sorry, something that occurred to me when you mentioned the contact lens example there. If you'd said spectacles, then you could have made a really good pun with frames per second.
Oh, I missed an opportunity. Thank you. Yeah, I'll save that one for later.
You can have that one next time. Yeah.
Yeah, thank you.
You've mentioned some really great examples here of real-world applications using edge computing and AI. I wonder if there are any others, like just one or two, that you particularly want to highlight as standout examples.
There's quite a lot. I'm very fortunate being at Arm. Arm is such a global company that we get to deal with these sort of global companies doing interesting things. I think the one thing I'm very curious about is how it's going to evolve in the consumer space. So, and you mentioned glasses. One of the things that's interesting to me is in the industrial space, we see vision being used to provide context for decision making. And I think we're going to see that emerge into the consumer space as well. So looking forward, I'd say, maybe spectacles or frames, these cameras that are present in our lives are going to allow us to do some really interesting things with context. So, maybe me looking at a menu and saying, what can I eat on here that isn't going to ruin my diet or make me put on even more weight at this stage, or, and it being able to take an image of that text or recognize there's text in front of you, recognize it's a menu locally, but then maybe pass that back to the cloud for a bit of an analysis of, I know Paul, I know his preferences, here's something he's going to enjoy or fits his lifestyle. So I think, this combination of edge AI agents that are doing this sort of event of interest screening and capturing context, combined with cloud agents that then do the deep thinking that we sort of see in the industrial space, I think it's going to be interesting to see that translate to consumer. But even in the short term, I see some really fun things happening. We have a team at Arm who, as part of our sort of community engagement, go out and work with others. And they're in the US, and they've been working on a project for identifying bears with cameras. So they have, in the Pacific Northwest, lots of bears roaming about, and they want to monitor the population. These simple remote camera traps can be augmented with AI to actually identify individuals and give live location information about which bear is where over time. And one of the exciting things about that project is, it's positively impacting the environment, it's helping people manage nature, but also the work that they did in that project, I understand, was shared globally, and that sort of bear tracking software has also now been deployed in Eastern Europe on other ARM-based systems by another group who've been using it to try and monitor the interaction between bears and humans in towns in Eastern Europe, where they effectively would prefer to scare away the bear rather than have a collision or interaction. So I can see that these algorithms that we can, develop potentially in the open source that run on these ARM accelerated compute platforms, you could buy a Raspberry Pi for $50 in Eastern Europe and go and roll that out really easily. And it's exciting to see both ARM's technology being underneath that and see, our team actually contributing to these sort of public projects in a positive way. So yeah, it's an exciting space.
Yeah, it sounds fascinating. Although I'm kind of glad you mentioned bears. Kind of glad that I don't live on the European continent where bears roam free. It's just a matter of distance if there's no ocean between you.
Yeah, that's true. And I'm the most my doorbell has to work out, smart doorbell is, is it a dog? Is it the wind blowing the trees, or is it the postman? Thankfully, it doesn't have to check it's not a bear knocking at the door. So yeah, it's the same kind of technology, but thankfully we don't have the scary side of it.
Yeah. As a sort of last final question there, then I think I'll ask you how we've seen huge amounts of change in edge computing over the last few years. How do you expect that to develop in the coming years, say the next 3 to 5 years?
Yeah, at the moment, we're really interested in a couple of trends that are showing this sort of desire, as we said, for higher performance computing. Part of that is the ability to run AI, which we've discussed. Another interesting evolution is the way in which software developers behave. So, historically, and certainly when I learned about developing embedded systems early in my career, it was, assembly code and deeply understanding the lower level hardware. Increasingly, particularly and accelerated, I think, by some of the use of AI, people are using higher and higher level software languages. So we're seeing people want to code in Python and want to do so on, Linux-based platforms, and that drives a requirement for higher performance compute systems with larger memory systems underneath to be able to support that. So we have to, at Arm, adapt to that change, make sure that the software and the tools allow them to do so efficiently, but also try and evolve the hardware underneath to try and maintain as much as we can the performance and energy efficiency when people move to these higher level languages, because by their nature they are somewhat less efficient and they require more resources. So we're in that balance of trying to make sure that that happens in a positive way, and we're investing significantly in software and tooling to support that transition.
That's brilliant. Well, thank you so much for joining me today. That's been really fascinating, and I hope eye-opening for our audience as well.
I hope so. Thanks very much, Tom. It's been a pleasure.
Thanks. Thanks for listening to this episode of Control Alt Lead. That is a wrap on our last episode of the year, but coming up in 2025, I'll have a whole new suite of guests and topics. And also look out for a new addition to our podcast stable. I'll say no more for now, but you'll find out all about it next year. As always, head to computing.co.uk for more IT interviews, research, and analysis. See you in January.